Hi, I'm Paul. I want to make a presentation about electricity from lemon to light the bulb. Let's start with the introduction. This is the basic theory of the experiment. Copper and zinc metals are used as the electrodes while the critic acid found in fruit is the electrolyte. The zinc is more reactive than copper, but copper atoms attract electrons more than the zinc atoms. As the attracted electrons concentrate on the copper, the electrons repel each other. The electrons on the zinc galvanized nail flows to the copper rod through an external circuit. The hydrogen ions in the fruit accept these electrons to form hydrogen gas, which explains why bubbling of gas is produced at the copper rod while two metals are connected by a wire. Zinc metals enter the electrolyte as ions, missing two electrons, zinc 2 plus. Two negatively charged electrons from the dissolved proton H plus in the acidic electrolyte combine with the two electrons from the zinc to form molecules hydrogen H2, which bubble off the copper electrode. The electrodes lost the copper are made up by moving two electrons from the zinc through the external wire. When the cell is providing an electrical current through an external circuit, the metallic zinc at the surface of the zinc electrode is dissolving into the solution. Zinc atom dissolve into the liquid electrolyte as electrically charged ions, zinc 2 plus, leaving two negatively charged electrons, E, e minus, uh, behind in the metal. Zinc turn into zinc 2 plus with electron. This process is called an oxidation reaction as zinc is entering the electrolyte. Two positively charged hydrogen ions H plus from the electrolyte combine with two electrons at the copper electrode's surface and form an uncharged hydrogen molecules H2. Two H plus with two electrons turn into H2. This process is called reduction reaction. The electrons are used from the copper to form the molecules of hydrogen as transferred by an external wire connected to the zinc. The hydrogen molecules formed at the surface of the copper by the reduction reaction ultimately bubble away as hydrogen gas. The lemon battery works well because it has an acid content. This is the objectives of the experiment. First, to determine whether if the fruit can produce electricity. Second, to determine whether the electricity produced by the fruit is able to light up the bulb. Third, to determine the relationship of the numbers of fruits and the power produced by the fruit batteries. Next, methodology. This is the apparatus and materials of the experiment. Multimeter, fridge bulb 15 watts, 240 volts, alligator clips, connecting wires, knife, zinc galvanized nails, copper roots, and lemons. This is the procedure of the experiment. Step 1. Lemon was rolled on a tabletop. Step 2. The slit was made at the opposite ends of each lemon by using knife. Step 3. Zinc galvanized nail and copper rod was inserted into the slits of the lemon. Step 4. The lemon was connected in series by using the alligator clips with connecting wires. Step 5. Bulb was connected to the end of the connecting wires. Step 6. The voltage and current flowing through the bulb was measured with multimeter. Step 7. The step 1 to 6 is repeated with 3 till 7 lemons by 1 increment each. These are the evidence of the experiment. As we can see, I'm using 1 lemon, 3 lemon, 4 lemon, 5 lemon, 6 lemon, and 7 lemons uh, to, to form the com complete circuit of the lemon battery. These are the results and the discussion of the experiment. This is the table of the experiment data of brightness of bulb, volt, current, and power from the fruit battery consisting of 1 lemon. As you can see, the bulb is not lightened up. The volt is small, 0.924 volts. And the current and the power is 0 because it is too small till the multimeter cannot detect the current. This is the table of the experiment data of volt, current, and power from the fruit battery of consisting 3, 4, 5, 6, and 7 lemons. As you can see, as the number of lemons increase, the voltage, current, and the power is increased steadily. To visualize that data, we plotted a graph of number of fruits vs power watt. The shape of the graph shows that the power watts is directly proportional to the number of fruits. This is the discussion of the experiment. First, does the fruit battery consisting of one lemon light up the bulb? Discuss it. The fruit battery of one lemon unable to light up the bulb. The current produced by the fruit battery of one lemon is so small until the multimeter cannot detect it. So the calculated power is 0. It cannot provide enough power to the fridge bulb 15 watts 240 volt, which need to consume 15 watts of power. Second, calculate the power of the fruit battery from the experiment data obtained and fill in table 2. By using Watt's law, P equals to IV, where P is power, I is current, and V is voltage. By using this formula, we find out that the power obtained from 3 lemons is 0.0056 watts. From 4 lemons is 0.0187 watts. From 5 lemons is 0.0373 watts. From 6 lemons is 0.0612 watts. And from 7 lemons is 0.0844 watts. 3. Plot the graph of the number of fruits and the power produced by the fruit battery. We have plotted the graph. According to the graph, what is the relationship of the number of fruits and the power produced by the fruit battery? The power produced by the fruit battery is directly proportional to the number of fruits. 4. From the fruit and vegetable of apple, orange, potato, cucumber, lime, lemons, and pineapple, predict which will produce a higher power. Discuss it. I predict lime because the acidity of lime is the highest. It is most suitable to be electrolyte of the fruit battery. Fifth, if you plan to develop a new system that can produce 20 watts of electricity power, how many of fruits or vegetables do you need in order to achieve the power required? By using Watt's law, P equal to IV, where P is power, I is current, and V is voltage. From this formula, we know that 7 lemons can produce 0.0844 watts of power. The power produced by 7 lemons battery is 0.0844 watts. Hence, number of lemons to produce 20 watts, we're using the number proportion method and find out that number of lemons to produce 20 watts is equals to 1659 of lemons. This is the conclusion of the experiment. From this experiment, I determined that the fruit can produce electricity. Then I determined that the fruit battery consisting 1, 3, 4, 5, 6, and 7 lemons unable to light up the bulb 15 watts 240 volt. I also determined that the power produced by the fruit battery is directly proportional to the numbers of fruits. From the experiment data, I observed that one lemon can provide approximately 0.923 volt and 0.003 ampere to the closed circuit.